Very good morning, all of you. This is Gautam Kashyap before you to teach you maths. First of all, I have to say something you all that as we know that whole world is suffering from a very hard time right now, and it is our responsibility to use our leisure time very properly, and especially for student of class 10th, we have to recognize the real utilization of our time. After this hard time, we will gather and carry on our studies, and that time we don't have enough time to revise the things and manage all that. So you have to ensure the things right now. You have to maximize your utilization of time and manage all those things that already taught, and try to memorize it, cover it very properly. Now moving ahead, yesterday we have completed exercise 1.1. Now we have to start exercise 1.2. Before starting exercise 1.2, we have to know a very important thing, that is fundamental theorem of arithmetic. It is important to know how can express any composite number as a product of primes. So let's start fundamental theorem of arithmetic. Fundamental theorem of arithmetic says that every composite number can be expressed as product of primes and product of primes. This factorization is unique. Apart from the sequences of factors occur. इसको थोड़ा सा हिंदी में समझने का प्रयास करते हैं कि फंडामेंटल थ्योरम ऑफ अर्थमेटिक जो होता है वह किसी भी नंबर को, किसी भी कंपोजिट नंबर को हम लोग प्रोडक्ट ऑफ प्राइम नंबर्स के प्रोडक्ट के रूप में हम लोग दिखाते हैं. उसमें एक बात बहुत ही साधारण सी बात है जिसको समझना है. वी हैव टू अंडरस्टैंड वेरी क्लियरली कि समझना है हम सबको कि वह जो फैक्टराइजेशन होता है वह यूनिक होता है. वह अगर यहाँ 140 है, हम लोगों ने 2 से स्टार्ट किया. 140 डिवाइडेड बाई 2 वी गेट 70. 70 इज डिवाइडेड बाई 2 वी गेट 35. 35 is divided by 5 we get 7. So here 140 can be written as product of 2, 2, 5 and 7. It is unique. In any way we try to factorize 140. There is no other factors than 2, 2, 5, 7. Here is a possibility that we can change the order of factors. We put 7 here and 2 here. We put 5 here and 2 here. Only we can change the position of the factors, but there is no other number except 2, 2, 5, 7 in it. So once again I try to make you understand that every positive integer can be expressed as product of primes, and this factorization is unique apart from the order in which the prime factors occur. So this is the fundamental theorem of arithmetic. Now moving ahead, we have to discuss about one or two formula that is related to exercise 1.2. That is related to exercise 1.2. That formula is HCF into LCM equals one number into other number. Here HCF equals one number into other number by LCM. LCM equals one number into other number by HCF one number equals LCM into HCF by other number, and other number equals LCM HCF by one number. Note, these formulas are applicable with only two numbers. We have already learned this formula, but right now in exercise 1.2 we have to use it in order to solve such problems. The formula is HCF into LCM equals one number into other number, and this and this formula is derived from this formula. So now we have to move on exercise 1.2. Now we have to move on exercise 1.2. One more thing that I want to tell, this formula are applicable with only two numbers. When three numbers given, we cannot use this formula in order to find HCF and LCM of these numbers. So moving ahead, we have to start exercise 1.2. 1.2. In this exercise, first we have to find prime factors of 256. We have to find the prime factors of this. So solving it, divide 2, 28, 2, 64, divided by 2, 32, 16, 2, 8, 2, 4, 2, 2. Now we can write 256 as product of these. So this is the way. In that way we try to factorize any number. In other hand, there are different type of questions also here. Is it composite or not? Now take 13 as common. One can be here. We see that here. We see that three factors here. So it is composite number. So exercise 1.2 have 5 or 6 questions. It is very easy exercise. So you have to solve exercise 1.2 with very good idea of solving problems. Once again, take care. Bye.